Okay, this is starting to get kind of messy. All right, so I've made some more changes if you haven't already gotten. So 2.2, just 1 to 25, odd. 2.3, imagine keeping the 1 to 21 odd, but you're skipping 7 through 19. So that means we have very few problems from 2.3. And I was hoping to go back and do some of that today. 2.4, let's make it 1 to 21 odd, 1 to 21 odd. And 2.5, 1 to 6 odd. This says 19 to 35 odd. Maybe I should rewrite it for you. 19 to 35 odd. Okay, so please note those. 1 to 25, 1 to 21 odd, skip 7 through 19. 2.4, 1 to 21 odd, 2.5, 19 to 35 odd. We're still on schedule to take an exam on Friday, but you can see there's much fewer sections than the first test. It doesn't cover as much material. And where are we? We are over here. Okay, so same ground rules as the first test. Now that you've been through one exam, you know what the others are all like. So same thing for Friday. Probably a little bit after 9 o'clock, I'll email you or actually send on Canvas announcements the exam, but I'll also project it for you. So just come join the class as usual. I'll take attendance not by calling on you. I have the whole hour to check who's there just looking at your name, so I won't call you. Mute yourselves. If you have a question during the test, send it me via chat, but don't unmute yourself. You can have your one cheat sheet, your formula sheet. And exam ends at what, 10 o'clock? So I'll close the meeting. You have 5 minutes, 10:05, to take pictures on your cell phone and submit your work. And then you have until 10:30 to submit the homework. Although if you want to turn in the homework early on Friday, that's also okay. All right. All right, so getting back to last time. So yesterday, I was doing a lot of 2.4 stuff. So I did 13 and 15, and here is 19 now. Come up with two functions for the composition. H of x is 1 over x plus 2. This is section 2.4. Again, ignore any dates. So the two functions are the reciprocal function, 1 over x, 1 over something, and x plus 2. The outer function is 1 over x. Right? And to tell what's the outer function, it's what you do last. So if you were given this function, right, you say, what do you do first? Do you do the 1 over or do the x plus 2? You add 2 first, right? And suppose I say plug in 3, you do 3 plus 2 first, and then you go 1 over. So that tells you the outer function is 1 over x, and the g of x is x plus 2. Right? So double check f of g of x, fog, f circle g of x. Okay, so f of g of x means f of x plus 2. And now what do you do to x plus 2? You reciprocate that, so 1 over x plus 2. All right? So that's it for 19. You can ignore all this stuff that's here. So I wanted to go back and give you that. Now, I'm pretty much done with 2.4, but I want to go back and quickly do some 2.3 stuff also. So back in 2.3. Now, I did give you these notes. I sent you an announcement, and I made my own little mini video with my cell phone, and of course it wasn't that satisfactory, so I'm going to go back over some of that. So 2.3, number 1. So the main idea behind 2.3 was to add, subtract, multiply, and divide functions. It really wasn't that big a deal. Okay, so here are two functions, f and g. So it asks for f plus g, just add them up. So 2x plus x squared plus 1, reorder it, x squared plus 2x plus 1. Domain is all real numbers. F minus g, you just subtract. 2x minus parentheses, x squared plus 1. Watch out, you need parentheses here. Distribute 2x minus x squared minus 1, negative x squared plus 2x minus 1. Again, the domain is all reals. Okay, say, how do you know it's all reals? There's no trouble spots. Any real number, you can square it. You can take its negative. You can multiply it by 2. You can subtract 1 and add them all up. Okay. So where would there be trouble? When you have a square root or if you're dividing by something, right? That's where you'd have to worry more about domain. F times g, you just multiply the two original functions. So it's just that times that, no big deal. 2x times x squared plus 1 comes out to be 2x cubed plus 2x. Domain is, again, all real numbers. And then f over g, f over g, you just take that divided by that, 2x over x squared plus 1. And at first you might say, well, there might be a limited domain because I'm dividing by something, but actually it turns out not to be an issue because x squared plus 1 can never be 0. X squared plus 1 is always positive, right? If you stop and think about it, once you square any real number, it can no longer be negative. The smallest the bottom can be right now is 0, but now you're adding 1. So the bottom is at least 1, so the domain is also all real numbers. Okay, and here was number 5. It's a little bit harder because of the square roots. Okay, so f was radical x plus 1, g is radical 3 minus x. Okay, so f plus g, just add them, and just leave it. There's nothing more you can do with that. In case you're wondering, can I go x minus x and 1 plus 3? No, you can't. You cannot do that for addition of radicals. You can do that for multiplication, but not for addition. Now, this one has a limited domain because you know when you take the square root of anything, of that or that, the thing underneath the square root has to be greater than or equal to 0. So I set both of these to be greater than or equal to 0. So x plus 1 greater than or equal to 0. And at the same time, 3 minus x is greater than or equal to 0. Okay, here, subtract 1, you get that. Add x, I think that's the easiest here. Add x, 3 is greater than or equal to x, which means the same thing as x is less than or equal to 3. All right, so both of these have to be satisfied. Okay, x is greater than or equal to negative 1. That means to the right of negative 1. And at the same time, less than or equal to 3. So that gives me this region here. So the domain is bracket negative 1, 3, bracket. That means you count the negative 1, you count the 3 also. Okay, f minus g, well, it's the same as this one, except instead of a plus, it's a minus. All the algebra is the same, so the domain is the same, bracket negative 1, 3. So no big deal for that. F times g, a little bit harder. So square root of x plus 1 times square root of 3 minus x. This time you are allowed to multiply them together. So I put it under one square root as this, x plus 1, 3 minus x. And now that product, that times that, has to be greater than or equal to 0. Okay, which leads me to the sign chart, right? So what number makes this 0? Negative 1. What number makes this 0? 3. Lay them down, do your sign chart. So number in region 1, negative 2. Region 2, 0. Region 3, 4. Okay, negative 2 plus 1 is negative. 3 minus a minus 2 is positive. So you have a negative times a positive. That comes out to be a negative. Is a negative greater than or equal to 0? No, that's false. Do not shade in region 1. Region 2, 0. 0 plus 1, positive. 3 minus 0, positive. Positive times a positive is positive. Is a positive greater than or equal to 0? Yes, that's true. Shade in region 2. Region 3, 4. 4 plus 1, positive. 3 minus 4, negative. Positive times a negative is negative. Negative greater than or equal to 0 is false. Do not shade in region 3. So again, I have bracket negative 1, 3, bracket. Okay. So far I'm getting the same domain as these. Okay. And then f over g is just one extra thing. So you're dividing. So you just take the original, that, divided by that. So radical x plus 1 over radical 3 minus x. Again, you're allowed to put it all under one radical. And then you want this to be greater than or equal to 0. Now, the analysis for this is exactly the same as the analysis for this, with one big exception. You're not allowed to plug in 3. Because if you plug in 3, you're dividing by 0. Okay. Other than that, the signs and everything would be exactly the same. So the only difference for this domain is here it's bracket negative 1, 3, bracket. Here it's bracket negative 1, 3, parenthesis, because we're not counting the 3 itself. Okay, so that's that. Skip that. Okay, so because of what happened last week, I decided to skip this, skip all that. Okay. And then one last problem was 21. Skip all this, skip all this. I decided we're not going to do that. But 21, again, 21 asks for the difference between x squared minus 4 over x minus 2 and x plus 2. So here's the original function f of x squared minus 4 over x minus 2. Here's g of x plus 2. And they're asking for the differences between the two. Okay? And yes, sometimes we get kind of sloppy with this in algebra. the top factors into x plus 2, x minus 2, and you notice, hey, I can cancel these out. So I have x plus 2. So at first glance, these two are the same function, but in reality, they aren't, because this function, x, is not allowed to be 2. Ultimately, this is the function, right? So if you were to graph f of x, it's the same graph as g, except you're not allowed to have 2. So you would punch a hole at 2, 4. How to get 2, 4? 2 is not allowed here. And what do you get over here when you plug in 2? 2 plus 2 is 4. So the graph of g would be the whole line. The graph of f is the line, except I punch a hole. It's like I puncture the tire there. I just throw out 2, 4. So the differences between the function is f of 2 is not defined, but g of 2 is defined, right? When you plug in 2, you get 4. When you plug in 2 here, it's not allowed because you're not allowed to divide by 0. Okay. All right, so I want to go and give you that from 2.3. And now I'm ready to start some of 2.5 stuff on inverse functions. A little bit longer section, but it's the last section now. Okay, so 2.5 on inverse functions. And I gave you all the stuff on inverse functions. And you should have seen some of this in your intermediate algebra. Stuff on inverse functions. Begins on what, page 111? Okay, so I'll be giving you my own notes about one-to-one functions. You can read what it says in the text, it's correct. 112 has one-to-one functions. 113 has the horizontal line test. Okay, and I'll give you that. Inverse function property. Okay, the way you write an inverse is with an f and a -1. Okay. We don't say f to the -1, and it doesn't mean reciprocal necessarily. Okay, it means f inverse. F inverse of f. Anytime you have a function and immediately do its inverse, you get the original back. And so it's a special composition of functions. We did compositions, the f of g, the fog stuff, and the Goff stuff, right? If you ever do a function and its inverse, you always get back the original. Okay, some properties of inverse functions. This is on page 115. Okay, the inverse function is unique. That means there's only going to be one. Okay, now, what's going to happen for the inverse functions is you switch around the x and the y. So the domain of one function becomes the range of the other. These two right here, that one and that one, they can be combined into one. The domain of one becomes the inverse of the other for the function and its inverse. The domain of f inverse becomes the range of f. The range of f inverse becomes the domain of s. That makes perfectly good sense because all you're doing is switching around the x and the y. Okay, this statement here is equivalent. F of x equals y means f inverse of y equals x. So notice what happened. They put the -1 on the f, and they switch around the x and y. So they say the same thing. So if you don't like the f inverse, you can make it f and just switch around the x and the y. And here's the inverse property function. If you have f inverse of f of x or f of f inverse, you always get back the original. Okay? So this is a special composition. If you compose a function with its inverse, you get the original back. Okay. Okay. This gives you a method of how you get the one-to-one, how you get the inverse function given a one-to-one function. You're basically just switching around y and x, and then solving once again for y. And I'll show you how to do that. Okay, so this is on page 116. If you need it on your cheat sheet, you can have it. But if you understand the process, I think you don't have to write this on your cheat sheet. Okay, but ultimately, you've got y and x, switch around x and y, solve again for y. And I want you to write it as f inverse. I want you to be able to write for me on the test and homework and quizzes or whatever, the f with the -1 there. Looks like an exponent of -1, but it's not. We say f inverse, that -1 there. Okay, and I'll show you what I mean by that. Okay, and a graphing property of one-to-one functions. The graph of f inverse of x is the reflection of the graph of y equals f of x about the line y equals x. So it's another reflection. So if you look at the blue and the red, they are inverse functions of each other. This time if you reflect across the line y equals x, which is a straight line going through the origin, going up at 45 degrees, okay, then the blue and the red are mirror images of each other. You can see there. So that's what they're saying over there. Okay, so now here are my notes. Now, I actually don't advise you to write this down, so I'm not going to slow down and wait for you to write this stuff. And you can look it back later on the video, and it's also in the book. Okay, so because of what happened last week, to save time, I have to pick up a little bit of speed because of this. So I'm not going to wait for you to write this down. You can look at it slower on the video later if you want. Or maybe if you already know this well, you don't need to write anything down, you just know it. Okay. All right, so the topic is inverse functions and also one-to-one functions. We sometimes write one-to-one like that, 1-1. So what's it all about? Okay, so we call a function is a relation such that for every input x in a domain, there corresponds a unique output y in the range. That means 1x will give you only one y value. Okay, so when we write this f of x equals x squared, when I plug in x here or here, you're only going to come back with one y value. You're not going to come back with two y's or three y's. Okay, 1x can only give me one y. There's a rule, like give me a number, I square it, or I cube it, or whatever. Okay, so if you have a function, that means any x gives you a unique y. There's only one output. There's only one thing that can come back, one particular y value. Okay, so again, I'm not going to slow down for you to write this, but you can look at it in the video later, and I'm sure a lot of you have heard this before. Okay, so 1x gives me only one y, and you know that functions pass the vertical line test. And again, you've heard of that before, so there's another reason why I think I can go a little bit faster, right? Because you've heard this before. So vertical line test. Notice the green here, if I draw vertical lines anywhere, it's going to touch at only one point at the most, right? So vertical lines drawn anywhere will touch the graph in at most one point. So y equals x squared, function, x cubed, function. Here's f of x equals 1 over x, which happens to look like this. Okay, it happens to be an odd function, which means there's a reflection across the origin. Okay, so it has origin symmetry. And if you replace x with negative x, you get the opposite of the original. All right? The domain of this function is all real numbers minus the set consisting of 0. Okay, but anyway, that's more than we care to know about right now. But it passes the vertical line test, as you can see. All right, now what is a one-to-one function? And you should have seen this also in intermediate algebra. Okay. So again, I'm not going to wait for you to write this down, sorry, to save time, but you can look back in the video later. Okay. A one-to-one function, so first of all, I've modified function with one-to-one, so it is a function, right? It's a special function, so I guess you can say one-to-one is the adjective that modifies the noun function, right? So it is a function, it still passes the vertical line test. A one-to-one function has a property such that each output y in the range, set of y values, corresponds to a unique input x in the domain. So one y has only one x also. So not only does one x give you one y, property of functions in general, but you also have one y giving you only one x. And I'll give you an example of a function which is one-to-one and a function that's not one-to-one. Okay, so f of x equals x squared. Okay, now let me pick y equals 4. Okay, so y equals 4. Suppose y were equal to 4. So behind my pen is 4. What numbers would make this a true statement? Well, x could be 2, but it can also be another number, -2. Right? So that means we do not have a one-to-one function because y equals 4 has two possible x values, -2 and +2. It's not one-to-one. So you can see from the graph of the parabola, when y is 4, x can be -2, and x can also be 2. On the other hand, f of x equals x cubed, I claim that is a one-to-one function, okay, because any y value, there's only going to be a unique x. Okay, so right here, suppose I said y equals 8. If y equals 8, x can only be 2. There's no other number it can be. If I say y, and by the way, you say, where's y? I don't see y. Well, f of x. F of x is equal to y. I know I could sneak in a y here. Okay. Suppose I said y equals 1. Then x is 1, not plus or minus 1, only 1. Suppose I say y is -1. Then x has to be -1 and nothing else. Okay. So this is considered a one-to-one function. Every y, there corresponds a unique x. It came from only one possible x. Okay? And that now leads us to the horizontal line test. So for one-to-one functions, a function is one-to-one if it passes the horizontal line test. That is, horizontal lines drawn anywhere will touch the graph in at most 1 point. Okay? So again, I'm not going to wait for you to write this down. Sorry. Again, you should have heard of that before, and you can look at the video later. But I think if you look at the examples, that probably sticks better in my opinion. Okay, so y equals x squared does not pass the horizontal line test. I can draw a horizontal line which touches at 2 points. So this is not one-to-one. However, for y equals x cubed, you can see I drew some horizontal lines, and it's only going to touch at 1 point at the most. So this is a one-to-one function. Now, both of these are functions, period. Okay? This is a function. It still passes the what test? Vertical line test. This still passes the vertical line test. Okay? So they're both functions. This is not a one-to-one function. It's a special function because it touches 2 points. This one is a one-to-one function. Let's call it a one-to-one function. Okay. Here's another one-to-one function. Y equals square root of x. Okay. So you should know quickly that square root looks something like that. And that'll help you on the exam, especially on Friday. So on Friday, you might be asked to do a variation of the square root. I expect you to pretty much know that its general shape is like this, or if you want, put it in your cheat sheet. But to graph y equals square root of x, you should not have to graph points, like 0, plug it in, 1, plug it in, 4, plug it in. You know, you should be able to do that quickly. Likewise, I think you should know these fairly quickly. And by the way, that's a special skill when you guys get to calculus. Your calculus teacher is probably going to want you to know right away x squared. You say, oh yeah, I know it looks like that. Or x cubed, quickly, it looks something like that. Okay, so your calc teachers, next time you take math and calc, they're not going to stop and plot a whole bunch of points. They're going to expect you to know, oh yeah, that's what x squared looks like. That's what x cubed looks like. That's what square root looks like, and so on. Absolute value, do you remember absolute value? Absolute value was V-shaped, right? Looks like a V. Right? So you should know that fairly quickly too. All right, so what I'm going to do right now, and these are very easy. I hope you'll agree with me. 1.6, sorry, what am I saying? 1 through 6, 2.5. We had to do 1 through 6 all. We can knock them all off now very easily. So 1 to 6 all. Very easy. Is it one-to-one or is it not one-to-one? Okay. And by the way, notice it says the function. So do you agree 1, 2, 3, 4, 5, and 6 are all functions? Right? What makes 1, 2, 3, 4, 5, and 6 functions? All 6 of them pass the what test? They all pass the vertical line test. Right? So for instance, look at number 2. If I draw a vertical line anywhere, it'll only touch at 1 point. Same for like 4, same for 6, right? If I draw a vertical line anywhere, it's only going to touch 1 point. Okay. But now for one-to-oneness, you have a one-to-one function if it also passes the horizontal line test. Right? So if it passes the horizontal line test, it's one-to-one. And if it does not pass the horizontal line test, it is not one-to-one. So we can knock these all off very quickly. Okay, so number 1, is it one-to-one? So number 1, the answer is yes. And by the way, on your homework, just put yes, or you can even just put Y. There's no work. So you know how I say, always show your work? These problems, there is no work. You know, the work is you just look at it and does it pass the horizontal line test or not. But yeah, in general, for quizzes and the homework and tests, if there's work to be done, you show me the work. Okay, so 1 is one-to-one. Number 2, is number 2 a one-to-one function? Hint, right here, if I draw a vertical line right here, it touches in quite a few points. So 2 is a no, not one-to-one. Okay, number 3, is number 3 one-to-one? Hint, no, right? So if I draw a line, well, I don't have to draw it. Just look at the x-axis. That's a horizontal line, right? It looks like it touches at 3 points. So 3 is not one-to-one. Okay, 4. And we're looking at horizontal lines. 4 is one-to-one. If I draw a horizontal line anywhere, looks like it's going to touch at only 1 point. So 4 is one-to-one. Okay, 5. 5 is not. Here's a horizontal line which touches at 2 points. So 5 is not one-to-one. And 6. 6 is also a no. 6 is not 1 to 1 because I can draw a horizontal line which touches at 2 points. Okay, so hopefully that was pretty straightforward. Okay, and now I'll start doing some of the other 2.5 stuff. So let's see. I'm sorry. Something's wrong here. I threw out too much. My bad. I threw out too much. Sorry, I still want 7 to 35 odd, but we're skipping 2 problems. Skip 15 and 17. Okay, so another modification. It's all messed up now, sorry. Part of it was because of last week too. So 1 to 6 odd, we just did it. Keep 7 to 35 odd. I'll do a bunch today, but skip 15 and 17. 15 and 17 don't really work in our situation that we're in. All right, determine if the given function is 1 to 1. All right, so you have to know something about the graph. Okay, so let me get my notes here for that. Okay, let's look at number 7. F of x equals 3x minus 4. Is it 1 to 1? So in order to do that, you have to know something about the graph. Right? So what is the graph of this thing? It's a straight line. Right? It's a line with a slope of 3 and a y-intercept of -4. You don't have to graph it, but something like that. So does that look like it's going to be 1 to 1? Yes, it is. Okay, so 7 is 1 to 1. Right? And if you need to give a reason, it's because, well, it's a line, it's linear. Okay, how about number 9? Again, you have to know something about the graph. Absolute value of x minus 1 plus 1. Okay, so I'm going to be very crude about it. You know absolute value. You should know roughly that's absolute value. Okay? And you should know something about this. This moves 1 unit to the right and 1 up. Okay? So 1 right and 1 up ends up looking something like that. Okay? In any event, it's an absolute value type. So does it pass the horizontal line test? No, it does not. So not 1 to 1. Right, so question number 9, not 1 to 1. Okay. Next one I want to show you was 13 because it's a piecewise defined function. Okay, so I'll show you the analysis for that. So for 13, is it 1 to 1? So we have 2x squared, x is greater than or equal to 0, x minus 2, x is less than 0. Okay, so let me show you this right here. Again, you don't need a very accurate graph, just a quickie graph. So just do something quick and dirty. Okay, now, you should know quickly what x squared looks like. Do you recall what x squared looks like? It's your parabola which opens up. And then what's the effect if I put a 2? Well, a 2 just makes it go sharper. It goes steeper quickly. So it goes to the origin, greater than or equal to, so 0, 0. So very crudely, it goes like that. And what does this look like? We're not allowed to plug in 0. Okay. I'm going to do it anyway just so I can put my open circle. So what happens when I plug in 0? I get -2. So open circle at 0, -2, right? Or you could say this is a line, straight line. The B is -2. So there it is. Slope is 1. Slope of 1 means it's going at a 45-degree angle. So there we go. So that's the graph. All right, does that look like it's 1-to-1? Yes, it is. It's a 1-to-1 function. And so you couldn't get that without the graph, right? I wouldn't be able to get that. So if you just showed this to me, if all of a sudden you just walked up to me and said, here's a function, is it 1-to-1? I couldn't do it that fast. I'd have to graph it. So I graph it and I graph it. And now take a look. Oh yeah, it does pass the horizontal line test. And yes, it still passes the vertical line test. Once you see f of x or g of x or anything like that, you know it's a function. It's a function period. But now is it a 1-to-1 function also? All right. All right, so now, if you have a 1-to-1 function, you have something called an inverse function. And inverse functions are for 1-to-1 functions. So if you do not have a 1-to-1 function, you don't have an inverse. Okay? And we went over these properties that are over here. So let me show you now how to do some of the problems at the end. So starting with 19, so again, we're skipping 15, we're skipping 17. We are doing 19 and on. Okay. Find the indicated value. So f of x is blah, blah, blah. So for these right here, right, they're all 1-to-1 functions because they say so. Okay. They have that f inverse thing over there. Okay. I'll just tell you generally what's happening here. Okay. They say f of x is blah, blah, blah. Find f inverse or whatever. Okay. Now, if they did not give you that -1, let's look at 19. Suppose they didn't have that -1 there. It just says f of 2. Then you know what to do, right? If it's f of 2, you plug in 2. Or if it said for 20, f of 0, you plug in 0. But it doesn't say f of 2 or f of 1 or whatever. It says f inverse of 2. Again, that -1 floating up there, it's not an exponent. It doesn't mean reciprocal. It means inverse. Okay? So one more time, the logic is if you see f of 2, then you say, oh yeah, I know what to do. Put a 2 right there. Since you have the -1, you must not be plugging in 2 for x. All right? So if I don't plug in 2 for x, where is it going to go? There's only one other letter. It goes in for y. Then you say, where's y? I don't see y. You pretend f of x is equal to y. So when it says f and that -1 there, that f to the -1 power, it looks like, but it's read f inverse. You don't plug in for x. You plug in for y. You say, where's y? I don't see y. Y is on the left-hand side here. Okay, so that's how you do 19 through 23. You plug in for y. Okay, so let me show you that right now. Okay, so f of x equals x plus 1, 2.5. Again, ignore any dates. F inverse of 2. So don't plug in 2 right here. And the logic is, if it said f of 2, I would plug in 2 here. It says f inverse of 2, so 2 cannot go in for x. It has to go somewhere else. There's only one other else that goes in for y. Okay? And the problem starts out, oh, I don't see any y. Well, change f of x to y. Now you plug in 2 right over here, you see. So 2 equals x plus 1. That's easy. So x equals 1. Right. So ultimately, the final answer is, what is f inverse of 2? It's 1. Okay? So it's just a different game. So all you do is, instead of plugging in for x, you plug in for y. Okay, here's 23. F of x equals 1 over x. Find f inverse of 2. Okay? So again, you don't plug in 2 here. That's what I would do if it said f of 2. But it's not f of 2, it's f inverse of 2. So you plug in 2 for y. So where's y? I don't see y. Replace f of x with y. So see this? I changed this f of x to y, and now I plug in 2 right here. You see? So 2 equals half x. Solve for x. Okay, multiply both sides by x. 2x equals 1. Divide by 2, so x is a half. So f inverse of 2 is equal to half. And yes, by coincidence, it happens to be the same thing for this example if I had just plugged in 2 directly. But that's not always going to be the case. Don't assume that you can always do that. Well, we know that didn't happen over here. Okay? It just so happens to happen in this particular case. All right? Okay, so I showed you how to do a couple of those. Okay, and last few minutes, how do you find the inverse? Okay, so find F inverse for the one-to-one function. So they're saying these guys are one-to-one, okay, and they also want you to graph the function and its inverse on the same coordinate axis. Okay, so how do you do that? All right. Okay, so 25, f of x equals 2x minus 1. Okay, I've already shown you the graph, but I'll hide it for a moment if you didn't see it. Okay, what's the shape of this? It's a line, mx plus b. Slope is 2. Very crudely, it looks something like that. Does that look like a one-to-one function? Yes, it passes the horizontal line test. It would also pass the vertical line test. So it should have an inverse. One-to-one functions have these things called inverses. So here's what you do. Call f of x y equals 2x minus 1. Okay. Now, switch around x and y. Okay. So wherever you see x, put y. Wherever you see y, put x. So switch x and y. That becomes an x. That becomes a y. And it looks like this. X equals 2y minus 1. Now just resolve again for y. So solve once again for y. Add 1, x plus 1 equals 2y. Divide by 2. And I've solved for y, but I want you to write this on the test. I want you to be able to write f inverse of x. I want you to see that notation. Okay, so divide by 2, you get a half x plus a half. So y equals f inverse of x equals 1/2 x plus 1/2. All right, this might be hard to graph, but it's easy if you think of it the right way. So again, the process for finding the inverse, the book went over that protocol. If you understand this, you don't have to read the book, you know what to do. So call this y, switch around the x and the y, and then solve for y again. Right? So that shouldn't be that bad. And just write it as f inverse of x. Okay, now, how do you graph y equals 2x minus 1? I have it in red. Okay. Slope is 2, y-intercept is negative 1. Okay, so ignore the green, ignore everything except the red for the moment. Okay, the b, the y-intercept is negative 1. There it is. Slope is 2, so over 1, up 2. So here's the point, 0, negative 1. If I go over 1 and up 2, I land here. What is here? It's 1, 1. 2 points are enough to determine a line, so I just connect those 2 dots, and I get that line over there. Okay, now how do I graph the inverse? Because 1/2, frankly, is kind of clumsy. Okay, I think the easier way to graph it is this. Okay. Just take these 2 points and switch them around. Okay, so if I switch around 0, negative 1, I get negative 1, 0. That's over here. Right? Maybe I'll write that for you for emphasis. Switch around 0, negative 1, 1, 0. Switch around 1, 1. Well, you still have 1, 1, so that stays. You know this is a line, so just connect those 2, and there's my inverse. So the green is f inverse, the f to the minus 1 thing. Here's the original f that I have in red. And there we have it. Okay? And just for emphasis, I put the line y equals x. The line y equals x is supposed to be the mirror image. Okay? The reflection of the green is the red across the line y equals x. And if you have a hard time seeing that because it's split into 2 parts, just split it into 2. Okay? Only look at that part. See y equals x. Okay? That looks like the reflection, sort of, if my graph were 100% accurate, which it isn't. Okay? And then look at this part separately, right? If I continue with the line y equals x, the green and the red, say, okay, it looks like one is a reflection of the other. Right? And it looks like the domain and range for both functions is all real numbers. Domain is all reals, and range is all reals for both of them. Okay. All right, let me see if I have time to set up 23, no, 27 for you. Square root of x minus 3. Okay. You should know quickly what the graph is. Okay, remember square root, square root looks something like that. Right? X minus 3 just moves the graph 3 units to the right. Okay, I'll show you that graph shortly. So it is a one-to-one function. So 27, please. Here's the function, f of x equals square root of x minus 3. Come up with the inverse. So first call this y equals square root of x minus 3. Switch around x and y. So wherever you see x, put y. Wherever you see y, put x. So x equals square root of y minus 3. Okay. Now isolate the y again. So how do you get rid of the square root? Square both sides. So x squared equals y minus 3. Add 3. And you have y equals f inverse of x equals x squared plus 3. Okay, and now for the graph. Okay, here's the square root of x minus 3. We said already that basic square root function starts at the origin and goes like that. If you replace x with x minus 3, just shift 3 to the left. So 3, 0, 4, 1. Okay. And now I can graph this just by switching points. If I switch 3, 0, you're at 0, 3. If I switch 4, 1, I'm at 1, 4. So it curves like that. Okay. And by the way, you notice, what's this x thing I have here? If you were to start off with x squared plus 3, right? That would be a parabola. That would be this whole thing. But we actually don't have the whole parabola. Okay. We only have the part that's a reflection of the square root function. Okay. So that part is not really there for the inverse. This is all we have. Okay, let's look at the original function. And again, notice the line y equals x. It's a reflection, it's the mirror image. So if I take the mirror image of the blue, I have the red. I don't have all this stuff over here, actually. Okay, what's the domain of this function? So I start the function at 3, and I go forever to the right. So that's bracket 3, comma, infinity. And for the range, the lowest y value is 0, range is for y, and it goes forever up. So bracket 0 to infinity. All right, so what happens for the inverse? Well, you can look at the graph, but we have a rule that says the domain of one just becomes the range of the other. Okay? So I just switch these two around. I'm going to say the domain of the inverse is 0 to infinity. And the range of the inverse is 3 to infinity. Right? So that was that principle. The domain of the function is the range of the inverse function and vice versa. Okay? And yes, that's borne out from the picture. If you look at the picture, the domain of the red is 0 to infinity. The range seems to be 3 to infinity. And that would not be the case if I kept the whole graph. If I kept the entire graph of x squared plus 3, right, then you'd have a much bigger domain. But it's restricted. It's only restricted to this part right over here. Okay. All right, that's as much as I was going to give you today. So let me stop the share. Okay, let me see if there's anything in the chat. I got nothing in the chat. Okay, so I guess there's nothing for me to worry about in the chat.
Mr. Tom?
Okay, and somebody has a question, yes.
Yeah, do we get a cheat sheet for this test?
I'm sorry, something about the test?
Yeah, do we have a cheat sheet or a little?
Yes, you get a cheat sheet for every test and the
Okay.
final exam also. Okay, so same thing, just get one sheet of paper, 8.5 by 11, both sides, and you can write down anything and everything that you wish for the test. Okay? Yeah. Let's see, what else is in the chat? I have nothing else in the chat, so 9:56, 9:57-ish. Anybody have something quick? Otherwise, we can call it a day. Will the questions we skip be in a test? No, of course that would not be fair. So when I said throw this out, I will not ask you any of those. We're different now. Everything's different, obviously. Maxwell, was your hand raised or no? Oh, okay. All right. Anybody else with anything? Oh, you're saying bye. You want me to stop. Okay. Yeah. Okay, anybody else, please? All right, so it looks like the game plan, I hope I can finish section 5 tomorrow. If that's the case, Thursday, come up with questions about anything. And just like last time, if you don't ask me stuff, I'm going to just go ahead with the next chapter. So your strategy is if you don't want me to start the next chapter, then ask me lots of questions on Thursday before the test on Friday. Okay, we've already had one test, so you know what it's like, you know, with the ground rules and everything like that, okay? All right, so anything else, please? All right, I guess that'll do it for today, folks. All right, so have a good day, and we'll see you tomorrow. Okay, bye, everyone.